Okay, so yeah, the next problem in the lead code is coin change. Okay, here's the code, but this looks different, lengthy compared to the online. It's just that I dragged it out. Okay, like to go match with the explanation and to easily understand, I just dragged it. Okay, we'll come to this later. So the problem is coin change. Okay, so what does it mean here is, so basically we have a bowl of coins here. So it consists of 1 rupees, 2 rupees, 5 rupees. Okay, and it's a big bowl. So why do I say it's a big bowl? It consists of infinite number of coins. It's not just three coins we have here. It has like infinite number of times. Like, I mean, 1 rupees we have infinite, 2 rupees we have infinite, 5 rupees we have infinite. Okay, so now the problem here is, like, we'll have to I need 11 rupees. I need to take it from the bowl. Okay, so what I can do is I can pick the two 5 rupee coins and 1 rupee coin. That will give me the 11 rupees, right? I'm done here. Okay. So I can also, I could have also picked 5 rupees, 2 rupees, 2 rupees, and it will constitute a 9 rupees. I might have, for the remaining 2 rupees, I might have picked two 1 rupees. Okay. So that will also result in 11 rupees, right? So now the question is, let's say that, okay, like I can pick n number of, I can do it in n number of ways to get the same result, correct? And also if I pick more number of coins, right, it will be too much on me to fit it into my wallet, correct? That's a problem for me, so I need to look for a way now to get the minimum number of coins. Okay, so and also we don't need to say that what number of coins to pick here. That's good. So that's good for us for this problem. We just have to say like what is the minimum number of coins that you can draw. Okay, so basically for this problem it will be this will be the efficient way to pick it, right? I will pick two 5 rupees, like that will constitute me the 10 rupees, and I can add 1 rupees. I'm done, right? This is within the three coins. I can get all the settled, all it settled. Okay, so okay, this is a problem. Okay, I hope it is clear. So let's say that now I want to pick up 3 rupees. In the next example, I want to pick a 3 rupees, but it has been given only 2 rupees here, right? If I pick only, like, I mean, only 2 rupees, like it's a infinite ball, but it's having only 2 rupees. I'll pick one 2 rupees and it is less than 3. I will try to pick one more 2 rupees. It will more than 3. It is not correct, right? So there is no way that we can get the exact amount. We should be getting the exact amount at any cost. It should be lesser, or it shouldn't be lesser, it shouldn't be greater. So if you're not able to find it, just return -1. Okay, and one more thing is, if you are not able to eligible to pay any amount from that bowl, you will have to return zero. Like how many number of coins that you are drawing exactly, it will be zero, right? That's what we are going to return it. Okay, so now let's see how we can solve this. Okay, so basically, okay, let's say that in the given problem, right, we can say this is a given problem of 11, and what are the coins that it has? 1, 3, 5, correct? I think it was 1 to 5. Let it be whatever it is. Okay, so this is the problem. So basically what we're trying to do here is, we'll be trying the n number of combinations here to get it to the 11, and we need to ensure that it will be whatever is minimum. To find out a minimum, we'll have to try out all the combinations here, correct? So like previously we have seen that whatever the problem, like we are struggling with, like, I mean, we are trying with the combinations, right? It can be solved by a backtracking, right? What is backtracking? Backtracking is again the recursion, right? We can use the recursion algorithm. Like, I mean, we can solve a recursion method to solve the problem, right? But here also we can do it, we can get an answer here. But the problem here is, like, is this list grows, right? We'll be running into too many of combinations, and we'll be repeating too many things, and it will be increasing time complexity. Okay, so now backtracking is not the way to go. Okay, and there is a greedy way also. I mean, greedy way is also not work here, like it has been explained in by other youtubers in the other videos. You can just check it out, but for now let's assume that it's not like, I mean, it doesn't work out. Okay, it will give us the wrong result. Okay, so now how we can improve this, right? How we can improve this approach? 11, right? Look, so basically how are we going to improve the backtracking? Basically one drawback in the backtracking is we'll be repeating the same operation again and again, right? So we'll have to reduce that, right? How are we going to reduce it? By storing it somewhere, right? So by storing those results, meaning caching, using the dynamic programming, we can improve this approach. Okay, so now let's see that how we can do it. So basically, whenever we are I'm seeing this pattern here, actually, like, I mean, I've not solved too many dynamic problems, but this is a pattern that I am seeing. You can reuse it, or maybe at this point of time this is working for me. Okay, so basically we are, as we know, like, I mean, to solve this any backtracking problem, right? So we need to know that what to store, correct? Like, I mean, we need to store, like, what the, we don't want to repeat the operation, we want to cache it. Okay, but we don't know like what to cache it at, right? So we want to analyze it first. So to analyze it, to the starting point will be to write a decision tree. Like, I mean, it's a backtracking, right? Basically, by the other recursion, like, I mean, we can just draw it in a tree way. Like, I mean, draw it in a tree way to solve the problem, correct? To solve the problem we can do it. And the first step to analyze like what to store and what not to store is to write a decision tree. Okay, so let's say that I am on a 11. Okay, as we are backtracking, like we started from 0 rupees, and we'll be finally taking the 11 rupees with us, right? But here, as we are backtracking, we'll be going backwards here. Okay, so let's say that if I'm 11, right, how could I arrive at 11? Like I might have picked some other, there is no direct 11 rupees coin, right? I might have still it will, if the one, though there is 11 rupees coin, it will constitute a plus 1 rupees. Like I mean, I might have picked one, at least one coin. Okay, so how might I have reached here, correct? So I might have reached here by picking any one of these coins, correct? So that tells us that I might have came from 10 rupees, right? I might have added 10 rupees, I added 1 to it, I might have got here. And I might have added 8 rupees, and I might have got here 8 plus 3 this one, okay, 5 rupees. Five, sorry, this will be 6. Basically we are subtracting it, basically, right? Whatever I add 11 rupees, and I will be subtracting it till I get a 0, basically. Okay, so that will be going to the from 11 to 0, as we are backtracking, right? Will be 11 to 0. So we'll be subtracting it. I'll subtract 1, I'll go to 10, subtract 3, 8, 5, and this will be 6 1. Okay, I might have, this is the way, right? This is like, I mean, after subtracting, I know that I could have come from 8, I could have come from 8. Like, I mean, if I possible, if I run the recursion, right, I might have tried this combination. Okay, so now what? So let's, for now, let's assume that it took 3 coins to build 3 coins to collect the 10 rupees. It took 2 rupees, 2 coins to build 8 rupees. Let's say for this one, it took you for, like, I mean, 6 rupees, 6 coins to build this one. Okay, I'm just giving the rough, there is nothing related to the example. Okay, so now simply what I can do is, if I know what I have already built, right? Let's say that it took 3 rupees, 2 rupees, 6 rupees, right? I already knew it. Okay, so simply what I can do is I can take a minimal, like, I mean, less amount, right? Because we need a less number of coins to pick. So I can simply pick this one, correct? So why do I pick this one, right? Like, I mean, why should I pick this one? I will not pick this two. I knew it. I asked 8 rupees, like how many coins that it took to build it. It said it was 2. I again asked for a say 10th one. It said it took 3 coins to build it. Similarly for 6, it took 6 coins, right? I simply take the answer from 8, because it is telling that this is the minimum value, right? So I can simply say, so far to build 8 rupees, it took 2 coins. Okay, and I'm going to 8 rupees, right? I'm going to add 3 more to it. I'm going to add 3 more rupees. I mean 1 coin to it to get a level. Okay, so if you check it here, what is the pattern that we are drawing here is, so to get 11, we are depending on the numbers 10, 8, and 6. Okay, whatever the, if we know what is the number of coins that it took to build it, we can simply take the minimum of that value and add plus one to it to get the result. Okay, so this is what is the backbone of this problem. Okay, so now let's try to analyze it further. I hope it's clear that how we actually draw this one. Okay, this is applicable everywhere now. So I'm just going to repeat it once. Okay, it will be clear. So basically, we had a 11 here. We are backtracking it. So backtracking meaning I might have come to this solution 11 from different ways. I might have had 10 rupees in my hand. Already drawn 10 rupees. I might have drawn 8 rupees. I might have drawn 6 rupees. This is not clear. Sorry for that. So I might have drawn 6 rupees. Okay. So how did we get this 1086? By simply subtracting. Like let's say that 11 minus 1 is 10, 11 minus 3 is 6, 8, 11 minus 5 is 6. Okay, so we are at this state. Okay, I simply add 1 coin to it. Like irrespective of what state I am, I will be adding 1 coin every time, right? Like I mean, I might have add 1 coin to get this result. Okay, plus 1 is there for sure. Okay, so now if I knew the answer for this one, right, 1086, how much coin it took to build 1086, I can simply take the minimum out of those values, because I need a minimum value at the end. So I can take a minimum value and add 1 to it to get the result. Why am I adding 1 to it? Because this is the answer to build so far. Okay, like I mean, how many coins that it took to build 8? It said 2. Okay, so currently we have 8 rupees in our hand. Okay, on top of it we are going to add plus 3 rupees, because this is 8, this is the problem, right? This is 3, this is 5, 1. I'm going to add 1 3 rupees coin to get the result. So that's why we'll have to add plus 1 to it to get a final result. Okay, so I hope it is clear. So basically what we are trying to do here is backtracking it here, and we know that this is depending, the bigger number is depending on the smaller numbers. Like I mean, 11 is depending on the 10 rupees. Like I mean, to build 11 number of coins, I need to know what is the number of coins that it took to build 10 rupees. It took to 8 rupees, and similarly 6 rupees. Okay, so let me clear this out. Okay, so now we know that 11 is depending on 8, 11 is depending on 10, 8, and 6 to get the result, correct? So simply, if we store the result of 10, 8, 6, right, we could have, if one second. Okay, sorry for that. So basically, now we know that 11 is depending on. So the answers are like 135. Like I mean, the coins are 135, right? And if we are solving for 10, like I mean, when we are solving for 11, we needed answer for 10, 8, and 6. Correct. Similarly, to solve 11, we are going to apply the same principle. Okay. Let's say that we are 10 here. Okay. So I could have come from 10 minus 1 is 9, and I could have come from 10 minus 3 is 11. So sorry, 10 minus 3 is 7, and 10 minus 5 is 5. I might have come from these values. Correct. If I knew the how much number of coins it took to build 9, build 7, build 5, right? I can take the minimum of these values and add plus 1 to it. Plus 1 to it, so that I can get like I mean, if I'm let's say that it give me, it took 1 coin, it took 2 coin, it took 3 coin, right? So what is the minimum value? This is the 9. This is the minimum value. Okay. So I'm currently at like 9 rupees. Okay, I've already built it. So it is telling me that it took only one coin to build it. Okay, and currently I have a 9 rupees in my hand. I'm going to add plus 1 rupees. Okay, plus 1 rupees to get it to the 10. Okay, so this is what is happening. Okay, we are trying to break it down. So basically, what does it signify? We have a number. It is depending on the lower numbers. Okay, so we need to store this value somewhere. Again, if you want to build it for 5, it is depending on the it is depending on the lower numbers again. It is depending on the lower numbers again. So it means to say that we'll need to solve the initial numbers first to actually solve the 11th one. Okay, so now let's write a dp array, how it looks. Okay, so now we know the dependence, right? So basically, we'll have to store all the result. Basically, we'll start from 0 to, actually, we could have stopped from 10 also, but we also need to solve for 11, right? Yeah, we'll 11. Like this will be our answer. Basically, to get this answer, we need to know how many number of coins that is taking to build each of them. So let's say that if we already knew it for 10, 6, and 8, right? It was 10, 6, 8, I guess. Yeah, 10, and because 11 needed 10, 6, 8, correct. If we know the answer for this, we could simply build the answer for this one also. Okay, it's the same principle for each, like whatever we solved, it is okay. So we'll have to pre-fill this value. Okay, so it is clear that we also see the example 3. Like I mean, if you are not drawing any number of amount, what will be the value? Like I mean, how many number of coins you are drawing? It will be 0. Similarly, like we'll solve for 1, 2, 3, and then we'll skip it because it will simply increase the length of the video. So let's say that I'm solving for 1. Okay, and the possible way is 135. What number I might have come from? 1 minus 1 is 0. I might have come from 0. 1 minus 3 is minus 2, and 1 minus 5 is minus 4. Correct. And is there any way that I have minus 2 in my hand? Obviously no, right? Like I mean, I'm not investing anything there. Like I mean, it's not possible. We need to ignore all the numbers that are greater than the current number. Okay, so I might have had a 0 rupees in my hand, and I added 1 rupees to it. Like I mean, I might have added 1 rupees to it. So one coin I've added, I will be incrementing by 1. So now I will ask the 0, how much coin did it take, took for you to build 0? Obviously that is stored here, that will be 0. So whatever the value minimum of this one, right? Okay, it will return 0. If there is any value, we'll also have to ask this guys also, like what is the number of coin that it took to build that number of coin. Okay, so basically it was 0. So we'll take, what is the 0 plus, we'll be adding one more coin to the top of it. This will be 1. So quickly check for 2. Okay, if we check for 2, 2 minus 1 is 1. 2 minus 3 is minus 1. 2 minus 3 is minus 3. We are not going to pick this one because those are negative. That's not possible. So now it means that I am coming from 1. There is only one way that I can come from. I can go to 2 by only 1. Okay. So if I add 1 rupees, I will be adding 1 more rupees to get a 2. Okay. So now again, I need to ask this guy how much number of coins it took to build you. It will say it as 1. So 1 plus 1, it will be 2. So it will take 2 coins to build you 2. Okay. I will be solving one last one. This is for 3. Okay. So what will happen here? 3 minus 1 is 2. Okay, 3 minus 1 is 2, and 3 minus 3 is 0, and 3 minus 5 is minus 2. Minus 2 will not take it, ignore. Okay, so now, okay, this is interesting actually. So 2, right? 2, 0. So I will ask, I might have came from 2 to 3 or 0 to 3. There is two possible ways that I can reach 3. Okay, so 2, I will ask this guy how many number of coins that it took to build you. So it will say that it took 2 coins to for me. Okay, and similarly, I will ask 0 guy, it will say 0 coins that it took to build for me. So obviously, what is the minimum value, like which is the efficient way? This will be the efficient way, right? So I will be picking the minimum of this value. So which is minimum here? This one, right? So for that, I'm going to add one coin to it, because currently we are at 0. Okay, this is the efficient. I know that if you come from 2, right, this is not be efficient because this is taking 2 value, this is taking just 2 value. Okay, 0 value. So currently I'm at 0. Okay, and so far it took only 0 coins to build me. So I will add 3 rupees. Okay, one coin, that will be plus 1. So what will be the answer here? For 3 it will be just one coin that it will take to build. Similarly, we can solve for each of them, and we can fill the values. Okay, ultimately like it will be keep on going. Okay, so we'll have to build this dpra, and we can higher value will rely on the previous one. Okay, to simplify the explanation here, we are going to start like we understood that higher numbers are depending on the lower. So that's how we decided we need to solve it from the beginning and not from the end. Okay, we got to know that. So whenever we are solving, we are trying the each combination, like we're checking for 1 3 5, whichever the valid, whichever the valid, we'll pick it. And if it is a valid, right, we'll be having the previous values already, so we'll be checking our dpra to get the minimum values. Okay, like out of all the three combination, we'll be checking the minimum one, and we'll be checking the minimum one, and we'll be adding one to it to get the current result. Okay, this is what we are doing. And also, let's say that if you are not possible at all, right, let's say that 3, let's say that 3, let's say we have only 4 rupees, 5 rupees, 6 rupees in the bowl. Okay, so so if you subtract it, right, everything will give you the negative values, correct? So if you are if it is not possible to build this one, so in that case you will have to set it as -1, because that's what is right. If you are able to not build 11, ultimately we'll also get a -1 here. Okay, now quickly check the code how it looks. So this is how it looks. Okay, like basically we'll be initializing our dpra, like just like we did it, right? We'll initially set it to 0, everything to 0. Okay, or we can set it to -1 also. I think the -1 would have been good way to do, I believe. It should be -1. And now here explicitly set the initial value to 0, like initial value will be 0, right? If the coin amount we are going to draw is 0, it will be 0. We can set it that way. Okay, and now what we are going to do here is for each of the targets, we are going to fill it. Like for 1 rupees, how many number of coins that it took. For 2 rupees, how many number of coins that we are going to take, right? That we are going to build it here. Okay, so this is a loop. Okay, so that's what we just solve for 0 1 2 3, right? That's what is this loop about. Okay, finally here, right, we need to try all this combination, correct? We'll have to try for one. If I add one coin, if I add 3 coin, if I add 5 coin, we'll have to try out that, right? We'll be storing that result in the temp variable. In online you can store there are other methods. You can simplify this code, but to make it clear, I'm writing it this way. Okay, so we'll be storing, creating a temp array, and we'll be trying out each of the combination now. So for each of the coin, we'll try the combination, we'll store the result in the temp. Okay, so whichever the value minimum, right, we'll store it in the this value. If we couldn't find it, if there is no none of them value returned something, right, we'll be setting the -1 to it. Okay, target one. So let's check inside it. So for each of the coin, we'll be taking the difference. Okay, if it is, it should be greater than 0, or else we'll be ignoring it. Okay, and then finally, and also it should not be negative, right? Like if it is a negative, we'll consider not as not found. Okay, we'll consider it as not found, and we'll be ultimately setting it as -1 here. So let's say that if the left amount is greater than 0 and it is not negative, we'll be getting the reading the value from the lowest value and adding the 1 to it. Okay, which this is the minimum value, right? No, this we'll be adding everything. We'll read it and we'll add it. Okay, ultimately here we'll do the calculation, which is the minimum one. Okay, that is it. Actually, this is the problem. This is how, like, we have improvised the backtracking algorithm with the dp method. Okay, so basically to summarize here, what we have done here is, as this is a problem about combination, right? Building a combination, we can simply use the backtracking here. And backtracking is a recursion, but recursion will have a problem that to it will have a repeated operation. To cut down that, we are going to store the operation. So that means it's a caching, or we can say it's a dynamic programming. Okay, so in the dynamic programming, like how are we going to analyze, like from where to start? So the first thing what we need to do is we need to write a decision tree, like from where to where we'll go, right? Actually, I just show the top view, but you will have to just see, like, draw the decision tree to. That's how we can analyze, like, what is depending on what. Sometimes you might need to solve from 11 actually. Like, sometimes you need to solve 11, 10, and you will get a final result for 0. But here, as the result was, this was depending on this one, right? We need to solve the earlier values first. Okay. Yeah, I think that is it. I think it's clear. Thanks.